Hi there. This interview focuses on how engineers actually think about monitoring and observability in real systems, especially when things break in ways you did not expect. I am going to ask you the kinds of questions that come up in real DevOps, SRE, and platform interviews, not trivia, but how you reason under pressure. As you listen, pause the video after each question and answer it out loud as if you were in the interview. Then compare your answer to the sample response and notice what you missed or what you would explain differently. If you want more interviews like this covering real production scenarios, subscribe so you do not miss the next one. Tell me about a time you were on call and received an alert that turned out not to be actionable. How did you handle it? In that situation, I first acknowledged the alert and checked whether it correlated with any user impact or other signals. When I confirmed it was noise, I still treated it as a problem to fix rather than something to ignore. After the incident, I reviewed why the alert fired, what assumption it was based on, and whether that assumption still made sense. I then adjusted thresholds, added context, or removed the alert entirely if it did not help decision-making. My goal was always to reduce future cognitive load for whoever was on call next. Describe a time when you had to debug an issue with very limited information. I started by slowing myself down and listing what I knew for sure versus what I was assuming. I looked for the simplest signal that could narrow the search space, such as whether the issue was global or isolated to a specific service or region. I also communicated early that we were still in the investigation phase, so expectations were set. As more data came in, I updated my hypothesis and shared findings openly. That approach helped avoid tunnel vision and kept the team aligned. Have you ever disagreed with how monitoring was set up on a system? What did you do? Yes, I have. In one case, the system had dozens of alerts, but most of them did not map to user experience. Instead of criticizing the setup directly, I asked what decisions each alert was meant to drive. That shifted the conversation from personal preference to outcomes. Over time, we refactored alerts to focus on symptoms users would feel and moved deeper metrics into dashboards for investigation rather than paging. Tell me about a time you helped improve observability, not just monitoring. I worked on a service where we had basic uptime checks but struggled to explain why failures happened. I added structured logging with consistent fields, propagated request IDs across services, and exposed key business-level metrics. This made it possible to trace a single request through the system and understand its behavior. The result was faster incident resolution and fewer repeated issues because we could finally see patterns instead of guessing. Let us start with fundamentals. How do you explain the difference between monitoring and observability to a non-technical stakeholder? I usually say monitoring tells you when something you expected goes wrong, while observability helps you understand what is happening when something unexpected occurs. Monitoring is about known failure modes and predefined checks. Observability is about being able to ask new questions of your system without having anticipated them in advance. For stakeholders, I frame it as the difference between getting an alarm and having the tools to investigate the cause quickly. Imagine a service is up, all dashboards look green, but users are complaining about slowness. What does that tell you? That tells me our monitoring is likely too shallow or focused on infrastructure health rather than user experience. The system might be technically up, but not meeting performance expectations. I would look for missing signals such as latency percentiles, queue depth, or dependency performance. This is a classic gap that observability helps close because you need visibility into how requests flow through the system, not just whether servers are responding. You are designing alerts for a critical API. What principles do you follow to avoid alert fatigue? I start by deciding what truly warrants waking someone up. Alerts should represent conditions where immediate action is required to prevent or reduce user impact. I prefer symptom-based alerts like high error rates or sustained latency rather than alerts on individual resource metrics. I also make sure alerts have clear runbooks so the on-call engineer knows what to do next instead of guessing. Let us talk about logs. Many teams log everything, yet still struggle during incidents. Why does that happen? Logging everything creates volume, but not clarity. Without structure, context, and correlation, logs become noise. The problem is not lack of data, but lack of useful signals. Effective logging focuses on intent and outcomes, includes identifiers that link events together, and avoids flooding the system with low-value messages. Observability is about making data explorable, not just abundant. If you had to choose only two out of metrics, logs and traces for a system, which would you choose and why? I would choose metrics and traces. Metrics give me fast feedback on system health and trends, while traces let me follow individual requests across services to understand behavior. Logs are still valuable, but without metrics and traces, it is hard to know where to look or what matters. In practice, I aim for all three, but if forced to prioritize, those two provide the most leverage. You are handed a legacy system with almost no observability. Where do you start? I start with the user-facing path. I identify the most critical request flow and add basic metrics around success rate and latency. Then I add minimal logging and tracing to that path to understand dependencies. I do not try to instrument everything at once. I focus on the areas that will give the biggest improvement in understanding and incident response, then expand iteratively as we learn more about the system. Let us continue by pushing deeper into how monitoring and observability affect real production decisions. Imagine you have excellent metrics and dashboards, but incidents still take too long to resolve. Where do you look next? I start by asking whether we can explain system behavior, not just detect that something is wrong. Metrics are great at telling us that latency went up or errors increased, but they often do not tell us why. I would look at whether we can follow a single request through the system. If we cannot answer questions like where time was spent or which dependency slowed things down, then traces are likely missing or incomplete. I would also review whether logs are structured in a way that supports investigation instead of forcing people to grep blindly. You are adding distributed tracing to a high-throughput service. What trade-offs do you consider? The first trade-off is overhead. Tracing every request can add latency and cost, especially at scale. I usually start with sampling and focus on critical paths or error cases. Another trade-off is complexity. Tracing introduces new concepts that teams need to understand, otherwise the data will be ignored. I also consider data retention and privacy. Traces can accidentally capture sensitive information if not handled carefully. The goal is enough visibility to debug effectively without overwhelming the system or the team. Let us say an alert fires for high CPU usage, but users report no issues. Do you treat this as a problem? I treat it as a signal to investigate, not necessarily an incident. High CPU by itself is not a user-facing problem unless it leads to latency, errors, or instability. I would check whether the service has headroom, whether garbage collection or background jobs are running, and whether this pattern is expected. If CPU usage does not correlate with user impact, I might downgrade the alert to a warning or move it to a dashboard. Alerts should represent risk to users, not just resource consumption. How do you decide what to measure in a system that is evolving quickly? I start with questions, not metrics. I ask what decisions we need to make and what failures would hurt users the most. Then I add metrics that help answer those questions. As the system evolves, I review metrics regularly and remove ones that no longer serve a purpose. Observability is not something you finish. It is something you continuously adapt as architecture and usage change. You are debugging a cascading failure across multiple services. How does observability change your approach compared to traditional monitoring? With traditional monitoring, I might jump between dashboards, trying to guess where the failure started. With good observability, I trace failed requests end to end and look for the first abnormal behavior. That helps me identify whether the issue is a dependency, a configuration change, or a load-related problem. It also helps me avoid fixing symptoms in one service while the root cause lives elsewhere. The key difference is that I am following behavior, not just watching graphs. Can observability ever make things worse? Yes, if it is done without discipline. Too much data without clear intent can slow teams down and increase costs. Poorly designed instrumentation can also introduce performance overhead or security risks. Observability should reduce uncertainty, not add noise. That means being deliberate about what you instrument, reviewing it regularly, and making sure the data is actually used during incidents and retrospectives. How do you measure whether your observability efforts are successful? I look at outcomes, not tools. Are incidents detected earlier? Are they resolved faster? Do engineers feel more confident when debugging? Are fewer issues recurring because root causes are understood? If observability data is not changing how teams respond to failures, then it is probably not delivering value, regardless of how sophisticated the setup looks. Now we are going to talk about situations where observability choices affect people, not just systems. You are on call during an outage, dashboards are lighting up, alerts are firing, and multiple teams are asking for answers. You do not yet know the root cause. What do you do first? The first thing I do is slow the situation down. I acknowledge the incident, communicate that we are investigating, and set expectations that we do not have answers yet. Then I focus on user impact. What are users actually experiencing and how severe is it? That helps prioritize actions. I resist the urge to jump into random dashboards. Instead, I pick one clear signal that reflects user experience and use that as an anchor while we investigate. Chaos increases when everyone chases different graphs at the same time. Leadership asks why the issue was not caught earlier if we have strong monitoring and observability. You are not fully sure yet. How do you respond? I am careful not to speculate. I explain what we know so far and what we are still learning. I might say that detection happened quickly, but understanding took time due to missing context or unexpected behavior. I frame it as a learning opportunity rather than a failure of tools. After the incident, I commit to reviewing what signals were missing or misleading and how we can improve. Credibility comes from honesty, not from pretending our systems are perfect. An engineer suggests adding many more alerts so nothing like this is missed again. What is your reaction? I push back gently. More alerts do not automatically mean better awareness. I ask what decision each new alert would drive and who would act on it. If we add alerts without clarity, we increase noise and risk people ignoring important signals. Instead, I focus on improving signal quality, correlation, and context. Sometimes the right answer is fewer alerts with better meaning, not more. During an incident, traces point to one service as slow, but that team insists their service is healthy based on their metrics. How do you handle the disagreement? I treat it as a shared problem, not a debate. I bring both perspectives together and look at the full request path. A service can look healthy in isolation, but still contribute to end-to-end latency due to interaction effects. I encourage the team to look at traces together and compare assumptions. Observability is most powerful when teams trust shared data and collaborate rather than defend their own dashboards. After a major outage, you realize observability gaps exist, but fixing them will take time and budget. How do you prioritize? I start with what would have shortened this incident the most. That might be better tracing on a critical path, clearer error metrics, or improved context in logs. I avoid boiling the ocean. I prioritize changes that directly reduce mean time to detect and mean time to resolve. I also balance quick wins with longer-term improvements, making sure leadership understands the value of investing in observability before the next incident happens. Take a moment to think about the questions you just heard. Monitoring and observability are not just technical topics. They shape how teams respond under pressure, how trust is built during incidents, and how confident engineers feel when systems behave unexpectedly. Which question challenged you the most? Was it handling uncertainty during an outage, deciding how much alerting is enough, or explaining gaps to leadership? Pause the video and answer those questions out loud. Listen to your own reasoning and notice where you hesitated. If you want to keep practicing real interview scenarios like this, subscribe for the next session. Each interview focuses on how experienced engineers actually think in production, and let me know in the comments which question made you stop and think.